Thanks all. Thanks Imran for that introduction. So the name of the company is Qubopt. My name is Will. I'm the only person in the company, so it might be easier to just call us Will. So what are we all about? I think if there's one message that I want to leave you with, it's that we believe in feeding your imagination with data. And the reason we think that's crucial is that the problems in the world that are hardest to solve, the problems that arise because of things like coronavirus or climate change, are all problems for which there's no simple solution. And normally they're difficult to solve because we don't have a model yet as to how they work. And traditionally, the way that we use data doesn't help you to answer these questions. But it's not normally so great at kind of providing inspiration for solutions. And I apologize already for the kind of gratuitous use of a genius in a slide. But I think his quote sums it up really well. Imagination is more important than knowledge, for knowledge is limited, whereas imagination embraces the entire world, simulating progress and giving birth to evolution. And if it's not too grand, then I think what we're trying to do is the second part of this. If you think of data currently as knowledge, what we're looking to do is use data to try to stimulate evolution. And the way that we're looking to do this initially is through allowing users to ask what-if questions. So what if we'd made different decisions? When we look at the rail network, when we look at the problems that we looked at in allocation, if we could go back in time and change the decisions we made, would it have led to better or worse outcomes? What if conditions had been different? So can we change the circumstances in which we're operating? Can we change the weather and see how it would affect outcomes? And then finally, and this is perhaps the biggest one, what if we could change our constraints? And so that means, what if we could take actions and make interventions which currently maybe even fall outside the scope of kind of current common decisions? And we think being able to answer these questions allows two fundamental changes to the way that we address business problems. The first step is diagnosis. So if we can ask the what if and we can answer the what if, then we can find out what causes poor outcomes. And if we can identify what causes poor outcomes, we can start to experiment and identify what optimizes those outcomes. And so, working with the fantastic people at TFW, we've been able to apply this approach to a real-world problem, which is short-form allocations. That is when there's no available train unit to satisfy a service with sufficient number of carriages. And what we've done is we've taken the data relating to schedules, relating to train locations, and we've used that to generate a dynamic model of the world. So this tries to predict at any one time what the state of the network might be and what the next state of the network might be. Using that model, we can go back in time, we can make an intervention on the data, and see what we think would have happened had some particular property been different. So if a different decision had been made. We can also then take that model and run it forward and try to imagine what will happen given some set of input data, some set of decisions. So working with short formations, what we do is look at the short formation that's occurred. We identify the list of allocation decisions over time that contributed to that. And then we start to sample from alternative decisions. Doing this, we can say, right, this short formation occurred over the course of these decisions, and at each stage, the range of possible options to avoid the short formation narrowed by some percentage. When you get these big drops or these big jumps in the percentage of a short formation happening, that's the decision that contributed materially to that occurring. So it starts to tell us why the short formation happened. And what we can then do is look to find the alternative set of decisions that would minimize that risk of the short formation happening. So we go from diagnosis to optimization. Now, I appreciate that we've not gone into a lot of detail here. Unlike some of the others, we don't have any screenshots to show you. But that's kind of deliberate, because I'm hoping you'll come over and speak to me more about this afterwards, and we can show you something. But before I leave, I would just like to say once again, thanks to the incredible team at TFW. Thanks to Michael, to Imran for setting up this entire accelerator scheme. And I think there's one thing that, again, I think would be great to leave you with. It's the idea that there are people out there who are applying this imagination that we talked about already to try and solve some of these hardest problems. And I think we've already heard from some of them this evening. We'll hear from some more as the evening goes on. So thanks a lot, and please do come over and speak to us.